Hey class, if you got this as a recommended video for your Unit 6 quiz, then it means you missed some question regarding confidence intervals for proportions. And remember, there's two main types, means and proportions. So with proportions, you have to look out for the keyword proportion or percentages. Like on this problem that you see to the left, you see the keyword proportion in several places, and then instead of a sample mean, it gives you a sample proportion. The formula for this would be, let me go back and get you the formula slide. Here are the formulas for margin of error. This one up here, and you can either use 1.96 or the 2. So margin of error equals 1.96 times the square root of p hat 1 minus p hat over the sample size n. So it's a little bit more complicated looking formula for margin of error than it was for means. Then, of course, once you get the margin of error and you have to fill in your confidence interval, then instead of a mu now in the middle, it's a p. And your lower bound would be p hat minus the e. The upper bound of the confidence interval would be p hat plus the e. So similar to what you did with means, you have to put the minus on the left and the plus on the right when you fill in the confidence interval boxes. So I'm going to pull up an example, show you how to work it by hand, but then also show you using the Unit 10 worksheet, Excel worksheet, which I think just makes this a lot easier in terms of doing the calculations. Okay, so here's an example. Assume the population proportion needs to be estimated. Find the margin of error and the confidence interval. So this one is a lot like number 10, if you missed question number 10 on the quiz. It gives you the sample size, which is our n. So our n equals 1055, and it gives us the sample proportion. Well, that's our p hat. As I had suggested in the Unit 10 seminar, I think it's much easier to immediately also do the 1 minus p hat, which is just doing 1 minus that number, and going ahead and getting this 0.676 value that you see to the left of your screen before you start putting it all into the square root stuff. It just makes it easier to store the stuff in your calculator. Of course, if you use the Unit 10 worksheet, Excel worksheet, you won't even have to worry about this stuff. So if I were going to do this by hand, then to get my margin of error, I would start by typing in 1.96 times, and if I were going to put this in Google, I would then have SQRT for square root, open parentheses. The p hat here comes first. Well, that was the 0.324. But then times the 1 minus that, which I already got, 0.676, and then divided by the sample size, which was the 1055 number. And put all that in the calculator, and then close all parentheses. So if I do this by hand, 1.96 times the square root, 0.324 times 0.676 divided by 1055, then my margin of error is the 0.028. And actually, I'm getting, oh, I see. I used 1.96. This slide uses a 2, and that's why they're getting something slightly different. When I use 1.96, I actually get 0.028. So mine gets rounded a little bit differently than the one here. But MSL should count it correct whether you use the 2 or the 1.96. Once you get the E, the margin of error, you then go back to your p hat and you do p hat minus that value. So you'll do 0.324 minus the 0.028 that you just got for the margin of error. So 0.324 minus the margin of error. That gives me 0.296. So again, you'll notice I'm getting slightly different numbers than the screen on the left, but that's because the one on the left I used a 2 instead of a 1.96. And then to fill in the box on the right, you've got to go back and do plus. So 0.324, which was your sample proportion, plus the margin of error. So 0.324 plus 0.028 would then give me 0.352. So that is how you calculate the E, the margin of error, and the confidence interval for proportions. The formulas by hand are just a little bit more complicated than they were for means. Now, if I use the worksheet, the Unit 10 worksheet, let me pull that up. All right, Unit 10 worksheet. So I knew my sample size. It was 1055. They gave that to me. My sample proportion, they gave that to me, 0.324. They did not give me the margin of error. That was something I had to calculate myself, so I don't fill in any more boxes, and I just go ahead and press enter on the keyboard. And here is my 0.028 number, along with the 0.296 and 0.352. This worksheet also used the 1.96. And you see that my answers agree doing it with what I got doing it by hand, but the main thing is you're going to have to rely on rounding correctly, because I think a lot of these are going to want you to round to 3 decimal places. So realize that you would round as I showed down here on the right when I did it by hand. If you use the worksheet, it's quick and easy, but you are going to have to be responsible for rounding it yourself. All right, so that is confidence interval for a proportion and margin of error for a proportion. Now, if that was a lot like question number 10, if you missed question number 12, which is also a confidence interval for proportions, it is pretty much the same as this one that we just worked out together. But in that one, they're going to go ahead and give you, let's see. Actually, it really gives you basically the same thing. I'm just reading that problem. So like that one gives you something. Mouse on here. All right, so on that one, they already give you it says a study concluded that, say, 32% of all student athletes had been subjected to hazing. Well, if it says a study was conducted to show that 32% were subject to hazing, you already know then that P hat is the 0.32. And then if it says the study was based on responses from 1,500 athletes, then you know that your sample size is 1,500. And remember, if I did this by hand, I would go ahead and find my 1 minus P hat right away. So I would do 1 minus my 0.32, get my 0.68, and then I'd be ready to plug into the margin of error formula, which is E equals 1.96, or you can use a 2, times SQRT for square root of the 0.32 times the 0.68, that's the P hat, oops, what just happened there, times the 0.68, that's the P hat and the 1 minus P hat. P hat, 1 minus P hat, divided by the sample size, and the sample size in this case, 1,500. Close that off and put this in the calculator. So 1.96 times the square root of 0.32 times 0.68 divided by 1,500. So when I do this by hand, I get a margin of error of about 0.024 if I round it to 3 decimal places. And then, of course, I would be ready to fill in my boxes by taking the P hat minus the margin of error. So if you did the 0.32 minus the 0.024, 0.32 minus the 0.024, I get 0.296. And then 0.32 plus 0.024, I get 0.344. There's both the margin of error and the confidence interval. If I were going to use the worksheet for this, Then I would come up here and put sample size was 1,500. Sample proportion was 0.32. And then press enter. And notice it gives me what I need. There's my 0.024 margin of error. Here's my lower bound 0.296 and upper bound 0.344. I just have to be careful with rounding. So whether you use the worksheet or do it by hand, that is how to do the confidence interval for proportions. And then the last question, which is number 13, you will also be doing a confidence interval for proportion, but you will have to calculate the p-hat by yourself. Like, for example, all right, so it might tell you that, like, let's suppose 970 out of, say, 1745 are in favor of some referendum. I'm totally making up some stuff. Well, that means you have to realize they're not giving you your p-hat. You would have to calculate it yourself by doing 970 out of 1745. Be careful about how many places they would want you to round to. So 970 divided by 1745 is about 0.556 if I round appropriately. And then you would go do, remember I like to calculate my 1 minus p-hat next. So that's 1 minus the 0.556, which is 0.444. And then I would be ready to calculate my margin of error and do the stuff by hand. And of course, that's going to be 1.96 times the square root of the p-hat, which was 0.556, times the 0.444. And you would have to realize that the sample size was the bottom number. 970 out of 1745 means you had a sample size of 1745. Put that in the calculator. Now, I personally like to just do this, use the worksheet. So over here, my sample size is 1745. My sample proportion we got was 0.556. And then I would go ahead and press enter and let it give me everything. I mean, if you work this out by hand, you're going to see that you should get these same numbers. But then the question is going to ask something about, is there evidence that a majority are in favor of the referendum or something like that? Well, in order to be a majority, you would have to have your entire confidence interval above 50%, because being higher than 50% means a majority. Well, in this case, it would give me evidence of a majority, because your lower bound of your interval is 0.533 if you look right there, and your upper bound is 0.579. So since the entire interval is above 50%, then yes, this would be giving me evidence that more than 50% or a majority of the population is in favor of the referendum. So that is similar to the last question on the quiz, which is like question number 13. But, I strongly suggest using the worksheets if you're having trouble with just the math part of things. The interpretation, of course, you've got to learn that. But the math, the worksheet will definitely help you out with this kind of stuff. So, if you're struggling with the calculator, just try to use the worksheets, and that might help you do better on the math part.